Hello everyone. Vivekananda College of Engineering and Technology is introducing a lab that is VLab at VCET. It is nothing but a virtual lab, wherein virtual lab you can work with different analog circuits and all the types of digital circuits, where you can simulate all the circuits related to analog design or the digital design and study or analyze the circuit accordingly. So because of this pandemic, the things have been shifted. Most of the things have been shifted to the virtual. Like theory classes are going on totally online. But what about the labs, laboratories? Physically, we may not. We may. It is not. It may not be possible to go to a particular lab and work over there for some of the students. So this concept that is VLab was brought into picture, wherein VLab you can work with all the components, with all the circuits, whatever you have it for your labs. All the circuits can be implemented or analyzed using this virtual lab. So in today's session, in this particular session, we will be giving you some basic information or basic ideas how to use this virtual lab with an example of a simple digital circuit, that is half adder circuit. Half adder circuit, here you can observe, if I consider the input as say A and B, two inputs, the half adder, in the half adder, you can observe the table here. If the input A is 0, B is 0, then sum is 0 as well as carry will be 0, right? Similarly, if A is 0 and B is 1, then the sum will be 1 as well as the carry is 0. If A is 1, B is 0, in that case also sum is 1 and carry is 0. If A is 1 and B is 1, sum will be 0 and carry is 1. So this half adder can be implemented using the gates as given here, like sum is equal to A XOR B, right? Sum is equal to A XOR B, as well as carry is equal to A and B. So sum is equal to A XOR B in the sense, suppose if input is 0, B is 0, 0 XOR with 0 gives us 0. If it is 0, 1, 0 XOR with 1 is 1. Similarly, if it is 1, 0, 1 XOR with 0 is 1, and 1 XOR with 1 is 0, right? So this table will be satisfied. Similarly, for carry also, you can just check it out. For 0 and 0, if A is 0, B is 0, 0 ANDed with 0 gives the carry 0. Similarly, if 0 ANDed with 1 gives the carry 0, 1 ANDed with 0 also 0, 1 ANDed with 1 provides the carry 1. Now, this is the basic half adder circuit, a simple half adder circuit. Now, the same circuit, how we can implement the same circuit in the simulation, that is virtual lab, we will just check it out. So in order to go to the virtual lab, one thing you require a good internet connection. Okay, so you can now open this particular lab in any of the browser like Mozilla or the Chrome, any of the browser you can open this particular virtual lab. Just I will shift to the Chrome now. Just click on this. The link for this particular simulation tool, that is VLab, it is cells.vcetputtur.ac.in/circuitsvl. So just type cells.vcetputtur.ac.in/C capital circuits VL in capital followed by a slash. Hit enter. You can observe the virtual lab tool, that is VLab. It will open. This is a home page. Okay, virtual lab. So just click on this. About it gives information about the Department of Electronics and Communication at VCET. All the informations will be provided there. If you click on this virtual lab, the tool where you are going to design, it will be open. Some circuit will be initially open. We need to reset it. We need to open a blank circuit and start with our own design. Whichever circuits you have, which it may be an analog circuits like an amplifier or a rectifier, any type of analog circuits or the digital circuits, any gates can be implemented using this simulation tool. So right now we will just go through how it can be used to implement the half adder. I will just explain you how the half adder can be implemented using this particular tool. we'll just open it in a full window. Just click on this particular option, that is full window. Yeah, here we have the entire circuit. Now, first step, go to circuits. In this, we have an option. See, you can observe there are so many circuits available in this. All the basic circuits like your Ohm's law or the resistor in order to study the working of the capacitor, inductor. So many already designed circuits are there, which you can double click on that particular circuit will open. Okay, and you can check its working. We will start with the new design. So directly go to the last option, that is blank circuit. Okay, click on this blank circuit. So this is the working window now. Okay, this is a blank circuit. We don't have any components over here. This is a working window where we are supposed to get the components for the required experiment and connect it accordingly and check whether it is working. Simulate. Checking in the sense we are going to simulate it. Check whether it is working as per the analysis or as per the table given. Okay. So for the half adder, as mentioned in this particular circuit, we require one XOR gate as well as one AND gate, very simple circuit. So one XOR gate and one AND gate is sufficient. So what we have to do is just, in order to get the components, either you can select here, this draw option can be selected, and under this you have various components available. You can select the components, or else in this window itself, in this blank window itself, you can right click, give a right click, and same options are available here. Say right now, if I consider XOR gate will be available. So there are different options here, like say wire. We need wire to connect the components. So this is wire. You need resistor. If you click on this, a resistor will open. Next, various passive components, inductor or switch, different components are available. Input sources like ground, the voltage source, DC supply, AC supply, all these are available. Next, output and labels. Outputs like say LED, or sometimes you may require a box, a text box, a voltmeter may be required, an ohm meter may be required. All these are nothing but the output components. Active components like a diode, a Zener diode, a transistor, a MOSFET. These are the different active components. Whichever is required, we need to pick. Right now, I require an XOR gate, which is available under the section logic gates. Okay, if I just select this logic gate and just move here, you can observe I require XOR gate. So click on this XOR gate, okay, and place the component. Just click on this anyway in between. Say like this, you will get. I will delete it. Two components have been placed. I will delete it. Again, I will select, right click. Next, logic gates, under this XOR gate. Okay, so just hold and drag, hold the mouse and drag. This is the XOR gate and click here. Okay, similarly, I require AND gate also. Again, right click, go to logic gates. Under this, I have an option that is OR gate. Click on this OR gate. Sorry, we require AND gate, no? Just again right click, logic gates, click on the AND gate. Okay, just click here and drag. So this is the AND gate. Okay, now wherever you want, you can move the components and place it anywhere in this particular window. Okay, I will place it over here. Now the components, whatever is required for the experiment is ready. Next thing is we need to join this. In order to join, we require wire. You can observe on the right hand side, shortcuts are also given. One option is right click and click on this wire. Okay, or else these shortcut keys also are given. So if I press W, wire will open. If I press R from the keyboard, resistor will open. If I press C, a capacitor will open. Right now I will press W. So you can observe this wire has opened. Now we have to connect two inputs, right? This is say if it is input A, connect from point to point. Okay, this should be shorted with respect to the input of the second circuit, right? This is my input A. Similarly, input B, I will consider like this, okay, and connect it to this point. Right now, the connection, this is first one is input A and the second one is input B. Now for this input A and input B, we have to give a supply, right? So in the truth table, we have seen if the input is 0, 0, the sum is 0, carry is 0. If input is 0, 1, sum is 1, carry is 0. right? So in order to give this input 0 and 1, 0 means 0 volt, say 1 is nothing but 5 volt. So some supply should be given. So in order to give the input, again same procedure, give a right click, okay, and then go to digital logic gates. Under this option logic gates, we have an option known as add logic input. Okay, if you click on this add logic input, okay, we will get an input. Say one input is this one, right? And the second input is here at this point. Just click here. Okay, these are the two inputs. Now, right now, by default, you can observe L mentions it is a low signal. If you want to change it to high, low in the sense it is nothing but 0. If you want to change it to high, just click on this L. See, now it has changed to high. Okay, if you click on this L, it will change to L, high. Again, if you click on that, it will change to low. So alternatively, we can set any of the input, either high or either low. So the input is ready now. Now you have to check the output. So output can be checked. Okay, output can be checked in different way, either through you can observe through waveform. Okay, or what I can do is I can have an LED at the output, light emitting diode, right? When the output is high, the LED will glow, or else it will be off. So right now in this particular session, what I will do is I will use both. We will observe the output through the LED as well as through the waveform. So first we will place the LED across the output. Again, same procedure, right click. Okay. Next, it is output source. Select this output and labels. Under this output and labels, you have an option known as add LED. So click on this add LED. If I click on this add LED, so we have to add the LED at the output. This is nothing but first is the sum. Okay. This is the LED, right? This is one LED across the sum, and second LED across the carry, that is across the AND gate. Okay. This is my second LED. The other end of the LED, this end, both the ends, it should be grounded. Therefore, in order to ground it, you can observe G is the shortcut for ground. Just type G in the keyboard. You'll have a ground. At this particular point, you select ground. Okay. Similarly, this also should be grounded. So click here and select. Now the circuit is complete. Okay. Now input is low. Both the inputs are low. So the output is 0, 0. I will change this. I will change this to high. Now you can observe. Now the input is 0 and 0, 1. If the input is 0, 1, 0 plus 1, the sum will be 1, correct? So you can observe here, this is sum. The LED has turned on. Red in the sense LED is in the on state. That means output is also high. Therefore, LED has turned on, right? Similarly, say if it is high, low, 1, 0, also sum is 1, carry is 0. So LED, sum LED is 1 and the carry is 0. If it is 1, 1, sum is 0, carry is 1. So here it has turned on. So this is how through the LED you are going to observe the output. Okay. Similarly, along with the LED, you can observe the output through the waveform also. Say if you just right click, if you select this output and right click on this, and if you give an option known as view in scope. Okay, view in scope in the sense you're going to observe the output in scope. Say this is the output across the AND gate. Say here you can observe at this particular time interval, the voltage has raised to 5 volt. Okay, this is the output of the AND gate. If you want to observe the output of the sum, again same procedure, right click on this. Okay, right click on this and view in the scope. So this is 0. You can observe here. This is the output of the first LED, that is sum, where the output the value is been displayed here, right? It is 0 initially, whereas here it is 1. Now if I change the input to 0, 1, you can observe the change immediately. The carry has gone to 0 from 1 to 0. Similarly, sum has gone to 0 to 1. This is how you can observe the waveform in the scope. Waveform you can observe at any point, the signal at any point of the input. It may be at the input section, or it may be the output section, or any intermediate signal between the circuit also you can check. Just right click on this and view in the scope. Any input signals or at any intermediate points also you can check the signal. It will be easy for you to track, or you can tell exactly at this point this is the input and at the output this will be the waveform. It will be easy for us to analyze the circuit. Okay, so this is the basic working of the half adder circuit using this VLAB. Okay, in the same way you can implement all the other circuits. Okay, all the other circuits you can implement. All the basic gates are available. digital circuit as well as analog circuit, and you can analyze the working of that particular circuit. Okay, so this particular session, this particular demo video, that is how to use a virtual lab, that is VLab, okay, as well as this demo video of this particular half adder. We will be uploading this into the website. You can just go through it and you can use this in order to understand the virtual lab and implement your own circuit. Okay, thank you all.